Part C, to find the angle between the line AB and the line L, right, it's actually more useful to write the vector equation of the line in this format where you separate this point here and then the direction here. Okay, notice the words I'm using. It's the same then with line L, right? You've got this point here and the direction. And what I'm talking about here, these are directions, aren't they? If you go back to my original part A here, if you remember, this is my line AB here written out like this. Okay, and of course it's a point on the line, yeah, with the vector equation O to A, which takes me to A, and then of course to get to my general point P, you know, I want to go from A to P, but you need to appreciate it's a fraction, isn't it, of A to B, yeah, lambda of A to B. But what I want you to notice is A is just a point, isn't it? That OA here. This A here, which I've got here is this here like a coordinate, that's just a single point on the line, okay? But what defines my direction, what defines where I'm going, is this vector AB, doesn't it, yeah? So what I've got here next to the lambda, okay, actually tells me the direction of this vector. I'm going along in that direction, A to B, yeah? I might be going further than B, okay? Or I might be going, you know, less than B. I might be stopping here, but in my diagram here, I'm going further than B. But the point is, I'm going along the direction. This is my direction of that vector AB. So AB, this thing after the lambda, it tells you the direction of the vector, all right? So when they ask for the angle between AB and the line L, okay, we want to think of the direction of these vectors, of course, to get the angle between them. Okay, so we're gonna use these two here. Okay, that's really important. So if you remember that formula, which in general is A dot B equals, and this is the general formula you remember, equals mod A mod B cos theta, right? So if you remember that there, we're gonna times these two together here. All right. So the other thing not to get confused with as well, this A dot B obviously has got nothing to do with these up here, right? That's just the general formula. Some people remember as P dot Q equals mod P mod Q cos theta. Okay, that might be more useful maybe. Okay, but ultimately it's these two here, right? These two define the direction of these two vectors, so it's these two you want to work with. So if we dot these together first, so we can work out what P dot Q is maybe then. I plus 2j minus 2k, dot that then with that, I minus j plus k equals, well, let's just dot them, so 1i there, times them, you get 1, 2j there, minus j there, so 2 times minus 1 is minus 2, and minus 2 there, 1 there is minus 2, so that works out to be minus 3, okay? And then, of course, we've got to do the mod of them, right? So the mod of that will be 1 squared plus 2 squared plus minus 2 squared. Okay, so my calculator, 1 squared plus 2 squared plus 2 squared. As I said, you don't bother put the minus in, but if you do put the minus in, make sure you put it in the bracket, okay? And you get that out, it comes out to be 3, okay? Same then with this one, so we've got 1 squared plus minus 1 squared plus 1 squared, okay, so 1 squared, this is easy enough, isn't it, plus 1 squared plus 1 squared comes out as root 3, doesn't it, okay? So then, following that formula, the dot of them is minus 3, equals then the mods times together, so 3 times root 3 cos theta. So then to get cos theta, of course, you just do minus 3, take that over the other side, and then you just do a cos inverse of that, right? Cos minus 1. Get my calculator. And if I type that in, I'm getting out to be 125.3 degrees.